All right, here's another graphing exponential functions. I enjoy doing these problems, so let's do another one. So I look at this guy here, wants me to drag the points around so that I get the graph of 4 to the x plus 3. And so I think the easiest way to do this is to recognize it as a graph transformation problem. So I think about, I start with the graph of y is equal to 4 to the x. And so that's a basic exponential function. And so I should have memorized what that looks like. It looks roughly like this. And there's two important points that I should note that are easy to find. I know that when x is 0, I should get 1, because if you set x equal to 0, 4 to the 0 is 1. And the other easy point is when x is 1, because when x is 1, then the y coordinate is just going to be 4. You can see that. And so, okay, so then let's see here. So then what is the graph of 4x? So why don't we plot those points just for fun here? So, all right, so we know we got the point 0, 1, and we have the point 1, 4. Okay, but the problem is what I just graphed here, that's the graph of 4 to the x. But we want 4 to the x plus 3. And so if you think about graph transformations, then you should know that when you replace x by x plus 3, what that's going to do to the graph is that's going to shift us. Wait, I meant to write a 3 here. Sorry. That's going to shift us to the left by 3. So, okay, so great. So all I have to do now is just take each of these points and move it left by 3. So 1, 2, 3, and 1, 2, 3. And that's all there is to it. So this is why graph transformations are so handy. With graph transformations, if you know the graph of one thing, then it's very easy to get the graph of a whole bunch of other things. And so that's a really good bargain, because that's what we're looking for in life. Our brains can only hold so much information, so what we want to always find are economical ways of remembering things. And graph transformations gives you a lot of bang for your buck. If you remember what the graph of one thing looks like, and you remember graph transformations, then you can get the graphs of a whole lot of other things very easily. Hello, we got another graphing exponential functions problem here. And now technically this is not an exponential function. This is a shifted exponential function because of the plus 3. If it was just 4 to the x, then it would be an exponential function. But the plus 3 means it's more like a shifted exponential function. But it's close enough. So, okay, so what are we? This is a fun one because I don't actually have to do much. I just have to move some points around. So this is fun. I get to move these points around so that I can make the graph. And okay, so let's see if we can do this. Make quick work of this. So okay, so I think the easiest thing to do is just plug in, just plot a couple of points. So plotting points, you might say, oh my gosh, that takes forever. But not really. Since all I have to do is drag some points around, this actually is going to be pretty fast. So all right, let's try plugging in x is equal to 0. So if x is equal to 0, then it's not too hard to see that you get 4 here, because 4 to the 0 is 1, and 1 plus 3 makes 4. And then if I plug in 1, then I get 4 to the 1 plus 3, which makes 7. Okay, so I'll drag this point. This has x coordinate 1. I'll drag it up to 7. And then this has x coordinate 0. So I'll drag it up to 4. And now I'm not quite done yet, because there's this asymptote. Oh, wow. I guess when I move it, it moves the whole thing, and that's not good. So I forgot where the asymptote was. I guess it was up at 1. And so, but I need to think about, well, where should the horizontal asymptote be? So what you need to remember about exponential function, so a regular exponential function. So like we said, a regular exponential function is one that doesn't have any plus or minus at the end. So a regular exponential function always has the x-axis as a horizontal asymptote. So if this was a regular exponential function, then the x-axis would be a horizontal asymptote. But it's not. It's moved up by 3. So what I need to do is actually then move that horizontal asymptote up to 3. And now, of course, now that I moved it up to 3, it messed up my other points. So I guess I guess I did it in the wrong order. But that's all right. We can put them back. So we know that when x is 0, we should get 4. Okay, so that looks about right. And when x is 1, we should get 7. So all right. So there's the point 17. There's the point 04. And we should have a horizontal asymptote at y is equal to, let me write that down, at y is equal to 3. This is y is equal to 3. And the reason for that is that a regular exponential function, just a 4 to the x, will have the x-axis as a horizontal asymptote. And so when you add 3, that's going to shift that graph up by exactly